C-style strings don't forgive, they overflow. And when they do, the computer starts reading memory like Google at 3 in the morning. What's up, everyone? Welcome back. Today we're talking about C-style strings in C++, the old, low-level, raw memory way of handling text. They're fast, they're powerful, and if you mess them up, your program doesn't warn you, it just loses its mind. Let me show you exactly what that looks like. C-style string is just an array of characters that ends with a special character called a null terminator. It's this here, right here. This is a null terminator. What's actually stored in memory looks like this, right? So that \0 tells the computer where the string ends. Without it, the computer has no idea when to stop reading memory. It's completely possible for us to access individual elements of this array, right? So we, here in this program, we want to access element 3, which is going to be x, right? So we can do Ctrl+Shift+P, right? And then let's do main.exe. And there we have x printed on the screen. Now what happens if I were to try and access the null terminator? The null terminator is going to be this one here, because we start our array at 0, 1, 2, 3, and 4. So what's gonna happen? Let's do main.exe, and there we have nothing. Nothing is printed to the screen. What happens if we try and access elements outside of that array, right? So let's do Ctrl+Shift+P. Let's do main.exe. And normally we will have some garbage character printed to the screen, but we can test it out, right? Okay, so we got the letter P printed to the screen, and as you can see, there's no P there. Let's see what happens if we were to print name. It's printed as is. Let's see what happens. Let's do Ctrl+Shift+P. Let's do main.exe. And there we have Alex printed to the screen. As you can see, Leonardo DiCaprio was explaining quantum mechanics at 3 AM, proof that reality is optional but effort is not. Let's do something scarier. Here, I declare a character array name, right? And then I declared a separate variable secret of type int, right? We're gonna see out. We prompt the user to enter a name. They enter a name, which is just a random string of characters, right? And then we output the name and we output the secret. So let's see what happens if I do main.exe, right? Enter some random garbage for name, right? And check what it does to secret. I never touched secret. Memory did. Here we have another example. This may look harmless at first glance, but when we manually enter characters into a character array like this, we need to include a null terminator, and here we did not. So now, what do you think is gonna happen? The computer doesn't know where the string ends, so it's gonna output a lot of garbage. It just keep reading memory until it accidentally finds a 0. And let me execute this so you see what exactly I mean. In this array, we have get, we wanna output the array, right? But that's not what's gonna be displayed. Now you can see here, we have some garbage output displayed on the terminal. So now let's talk a bit about dangerous string functions. Functions like string copy and string get are famous for this, right? So they do zero size checking. They just copy until something breaks. If I were to compile this, right, my compiler is going to give me a warning. Now I do main.exe. This is still going to run, but we don't know what is happening underneath the hood, right? If I were to put more additional variables here, this may have interfered with those, you know. It's important to note that this can crash your program, it can corrupt nearby variables, it can cause random unpredictable behavior, it can create serious security vulnerabilities, and this is how real exploits start. So why learn C-style strings at all? Because they're everywhere. Embedded systems, operating systems, PLCs, drivers, cybersecurity tools. If you don't understand this, you don't fully understand memory. If this helped, drop a like, subscribe, and tell me what you want me to do next.